One more topic that often gets included when talking about curve sketching is slant asymptotes. You might be used to horizontal and vertical asymptotes, but we can actually get other kinds of asymptotes. Let's think about a function like 1 over x squared plus 3. As x gets very large, then the bottom gets even larger, and so you end up with the function just going to 0. So it looks something like this. And we can say there's a horizontal asymptote at 0. Here's 0. What if we did not 1 over x squared plus 3, but x over x squared plus 3? Well, when x is 0, here at 0, when x gets large, the plus 3 doesn't really matter, and you've got basically x over x cubed, x over x squared, which is 1 over x. So that's also going to have a horizontal asymptote at 0. At y equals 0, we're saying. So that was x to the 0, x to the 1. Let's do x squared over x squared plus 3. Again, at 0, you've got 0. For large x, the plus 3 doesn't matter. You basically have x squared over x squared, which is 1. And so you get something like this. And you get a horizontal asymptote of 1. So we've got x to the 0 over stuff, x to the 1 over stuff, x squared over stuff. The next thing to try, obviously, is x cubed over stuff. And then that's where life gets interesting. Again, at 0, we have 0, and then it has a little kind of bobble, but then does that. And it's approaching an asymptote of basically y equals x. You can imagine for large x, the plus 3 doesn't make a difference because the x squared is so big already. I mean, it makes a very tiny difference. So you basically have x cubed over x squared, which cancels to give you just plain x. So that's why it's approaching this slanted line of y equals x. So we'd say this is a slant asymptote of y equals x. Not all slant asymptotes are y equals x. Of course, if you throw a multiplier on here, you can change the slope. And just to continue the pattern here, x to the 4th over x squared plus 3. Well, again, for large x, the plus 3 doesn't really make much of a difference. You basically have x to the 4th over x squared, which is going to be basically like a parabola. I guess you could say it's a parabolic asymptote. I'm not sure if anyone says that, but you could be the first.